Here we have to find out the transfer function of the tachometer, whose input is pi of t, whose output is e of t. Suppose tachometer input is given in radians, whereas output e of t is given in volts. E of t equals to Ka d pi of t by dt. Here the units of Ka are volts per radians per second. Units of d pi of t by dt is radians per second. Hence the E of t units are volts. If we apply the Laplace transformation to the equation 1, we will get E of s equals to Ka s pi of s. So E of s by pi of s equals to Ka a into s, which is a transfer function of a tachometer. Hence the option D is true.
In this problem, it is given that a box contains 5 black and 5 red balls, of which 2 balls are drawn one after the other without replacement. Now we have to find the probability that the both balls being red. Now the total number of balls are 10, of which there are 5 red and 5 black. Now when we are drawing the first ball, probability of getting a red ball is out of the total outcomes, that is 10 10c1, we are selecting one from red, that is 5c1, which is nothing but 5 by 10 equals to half. Now when we are selecting the second ball, probability of getting red is 4c1 by 9c1. The reason is we are not replacing the ball. So out of 10 balls we have taken one ball, so the remaining are 9 balls, and out of 5 red balls we have selected one red ball, that is there will be only 4 red balls left. So the answer will be 4 by 9. Now the required probability is nothing but the product of these two cases, which is 1 by 2 into 4 by 9, which is 2 by 9. Option D. We have to evaluate the integral z plus 5 by z square plus 2z plus 5 dz. Now in order to find this integral, we have to find the poles of the denominator, that is z square plus 2z plus 5. In order to find the poles, we'll equate it to 0. Now the value of z will be minus 1 plus or minus 2i. Now the value of r is nothing but root over minus 1 square plus or minus 2 square, which will be root 5, always greater than 1. That means these poles lie outside the unit circle. So if the poles lies outside the unit circle, the value of the integral will be always 0. So therefore z plus 5 by z square plus 2z plus 5 integral will be 0. That is option B. Now in this problem, the given function f is xyz cube. We have to find the gradient of f at 1, 0, 2. Now the gradient is nothing but delta f, which is nothing but dou by dou x of xyz cube into I plus dou by dou y of xyz cube into j plus dou by dou z of xyz cube into k, which will be nothing but yz cube into I plus xz cube into j plus 3z square xy into k, which is nothing but delta f. Now delta f at 1, 0, 2 will give you 8j. Just substitute the value of x as 1, y as 0 and z as 2. Now gradient is modulus of delta f, which is equals to modulus of 8j. That is nothing but root over 8 square, which is again 8. So the option B.
Here we have to find out the resonance frequency. First of all, we need to know what do you mean by the resonance frequency. Resonance frequency is the frequency where the magnitude of the given closed loop transfer function is going to be maximized. The relationship between the resonance frequency and the parameters of a closed loop transfer function is given as follows. Resonance frequency equals to the natural frequency under root 1 minus 2 zeta square, where zeta is the damping ratio, omega n is the natural frequency. Units are radians per second. We can obtain zeta and the natural frequency from the closed loop transfer function of a given diagram. Now the closed loop transfer function equals to 16 by s square plus 4 plus 16, which is compared with the standard one. From this comparison, we are going to get omega n equals to 4 radians per second, 2 zeta into 4 equals to 4. Zeta equals to 0.5. So if we substitute omega n and zeta in the equation 1, we are going to get omega r equals to 2 root and radians per second. Answer A. Here we have to find out the z transform of a given function x of n equals to cos of pi by 3n u of n. We know cos theta equals to e power j theta plus e power minus j theta by 2. By using this above standard relation, we can write x of n as 1 by 2 e power j pi by 3n u of n plus 1 by 2 e power minus j pi by 3n u of n. By using the standard z transform relations, we can convert x of n into x of z as follows. X of z equals to 1 by 2 1 divided by e power plus j pi by 3 z inverse plus 1 by 1 minus e power minus j pi by 3 z inverse. After simplification, x of z is going to be z into z minus 1 divided by z square minus z plus 1 mod z greater than 1. Here the option is D.